Today we will have a lecture with Professor Oliver Sachse from Germany. So please listen, please enjoy it. And afterwards, of course, we will have the rest of the classes, so you will not miss your tutoring today. But for now, you can just take your time and have the lecture. Okay?
Thank you very much. Welcome from my side. I'm going to talk about construction and construction and architecture, kind of with a point that construction is architectural design. It's an important part, kind of an integrated part of architectural design, and has a lot of potential to work with, to define spaces. And so I'll try to make an argument for it and show some examples how that works. If you have any questions in between, I'll try to make a small break maybe in between. And if you have any questions, just raise your hand or somehow let me know. So yeah, there are like two images that have to do with it, and especially the right one, it's a student work, really fascinated me because of its beauty, and it's a pure structure. It's kind of really showing the point I'm heading to, that structure is design. First, let me introduce myself a little bit, because we don't know each other yet. My name is Oliver Sachse, that you might know. I'm teaching at the University of Applied Sciences in Erfurt, and doing guest professorship this semester, and actually mainly in the second year. I actually live in Berlin, so these are like kind of the spots I'm moving in between in this semester. Erfurt is a beautiful city, actually, like 200,000 inhabitants, quite a bit smaller than Krakow. Has a very historical center, and we also have a nice historical building. It used to be a drawing school, actually, from its beginning, so always had to do something with architecture. We have at our school a certain focus on what I would call constructive architectural design. We call it constructives Entwerfen. So really like this integration of these two ways of thinking, maybe, or kind of with the argument that's actually the same. And so we're working a lot, and you can see it in these students' work examples already, that kind of the structure has a lot of expression. It has a lot of, gives a lot of atmosphere to the spaces that are constructed with these structures. It's also moving forward into the detailing, because it doesn't stop with a system, an overall system, but it's really also about how things are then taken a little bit further into the detailing. And all these things, the detailing, the system, they belong together. It's always about, it's not about construction in itself. It's always about spaces that are constructed. And these are also like second year work examples of our students that are working with structures to create a certain atmosphere in their designs, in their projects. This I put in because as a student, quite a while ago, I got in touch with structural engineers. Actually, it was in a class, a design project class. And we had consultations with Manfred Grohmann, who became quite a famous German engineer. Did a lot of outstanding buildings, the structures for outstanding buildings. And so I learned about kind of the other constructor and the way that architects and engineers work together. And it fascinated me, because I also had a feeling, I probably by that time couldn't express it, but something was very interesting. So I applied and started to work at their office as a student. And this was like one of the projects I was working on, being a small part of it, but very interesting one. It's a pavilion for the BMW at the car fair in Frankfurt by Franken Architects. And so it was a lot about how to basically have this shape, which was kind of the idea, was a very formal idea. And then the question, how could we build this in a very short time and kind of make it also demountable? And yeah, basically looking at the details, how could we resolve, how could we deal with such a geometry? That was a main part, and how could we really make it work as a structural system? So that was kind of my first time I got in touch with this issues in a project. So we're talking about construction, and I always like to look into what does it mean, what's the word about, because if you look at where a word comes from, it often tells you a lot about the character of what the notion actually means. So what is construction? If you look at the word's meaning, to construct means to design. So it's kind of supporting my argument, to erect, to build. And it also has a grammatical meaning. It's arranging words or sentences or sentence elements together. So it's really like something that comes from language. And it means putting single elements together so they form a whole, so they form a sentence, something that has a meaning. And I think it has a lot to do with what we are doing in construction. So construction means the design, the building, the joint of words or sentences to create meaning. And it comes from the Latin constructio. It is a combination, con and struere. And struere is kind of saying it's the kind of piling things up or putting things on top of each other or kind of join them together. That's where the word comes from. And it got used actually first as a grammatical term and became certainly, as you all know, a technical term. So there were many kind of different ways construction is used. You could use it either as a design or thinking process through the development, kind of how could we do it? How could we construct it so it works as a construction, as a real physical building? It could also be then kind of a next step. The physical process of erection is also called construction. And also the result in the end is called construction. So what's then finally standing there? And I already pointed it out a bit, but I think it's very interesting aspects that kind of lie in this meaning of these words. So it's kind of the notion of the idea of joining elements together so they form a meaningful whole, something complete, kind of creating a system as a whole. And it also has something, an aspect of a project, which I also think is a very nice idea. The term project has a lot to do with a projection. So it's basically a project is something that you have as an idea, which is not realized yet, but is kind of thought to be realized someday, sometime. And well, you all know this design process. It's kind of the projection, kind of so one-directional. The processes actually do not work that way. It's kind of a circle. You do something. You have a thinking. You have an imagination. You put it down on paper or on a model. Then you look at it. You kind of can then criticize it and go back and develop your thinking. So it's a circular process that certainly goes maybe like a spiral and moving forward. So this is about kind of the term we're talking about construction. Now the question is, how do we actually work in architecture? How do we form space? And if we're looking at the formation of space, how does it exist? You can say that's kind of the outer space, something that has no limits, maybe just horizon. So there's actually not really something you could, as a person, relate to. And actually, there's a nice book about thresholds that I took this from. It's an example from super studio that kind of work within that space, and they kind of trying to structure it in a way. So it needs some structure. According to Descartes, in that book says, the world is a spatial continuum, and thresholds only exist to the extent that they are produced. And that's what we are doing. We're kind of producing thresholds. We're producing limits to space, kind of really to define a space. How does it work? It could work just by kind of having a plain crowd and putting some area, kind of put a border around it, and there you already have kind of a definition. You have something that is above that ground. It's kind of a spatial, first spatial definition. You could also say, I put a wall somewhere, and then you suddenly get something, kind of a space in front. That's where you are, and something that is behind it. And so there is kind of a division, there's a definition of space, of spatial qualities as well. And if you put a couple of walls and arrange them in a three-dimensional way, you get something like an inside and an outside. So it's not like in front and behind, but it's inside, outside. And if we put a roof to it, it becomes below. So that's the formation of space through construction. There's something doubled. So space is actually formed by defining the limits. And that is actually what construction does. It makes these limits. So if we're thinking about how to create space, actually the construction is our means, our kind of tools that we work with in order to create space. The physical elements, and as long as they are not built as physical elements, it's kind of an idea of a physical element. So then you have kind of limits, and there's still another very important thing, and this has a lot to do with constructing, in this meaning that I just mentioned before, that it's kind of forming a whole, kind of that makes a meaningful, makes a meaningful whole, a meaningful system. It's basically the way that these parts are put together. So you can imagine if you have like a roof, a wall, and they're not connected, you're not really getting kind of a really enclosed space. You still have kind of air coming through, et cetera, et cetera. So you have to join these elements to create a whole. And then you get a system. These things kind of interact with each other, they cooperate, they create a system in itself that is actually more than just the addition of the parts, because they are joined together in a sensible way. And that is what architecture is. Architecture is a system. It's a system of elements, of building elements that actually act in combination to each other, that kind of connect these elements, and that actually also works on different scales. So it works kind of from the big picture, kind of the outer volume, the image that you have from the outside, towards the interior spaces, towards how things, actually the elements are assembled within themselves, and how they're connected to each other. All that kind of forms one system to create a whole. And this whole, as I just said, is more than the sum of the parts. I think that's becoming obvious. So why do we do it? Certainly to create protected spaces, socially protected spaces. In the beginning, certainly climate protected spaces, or it's still very important. We want a warm condition in here, not too hot. If it's getting really hot outside, we want it a little bit cooler. If it's in winter, we want it warm. We want it protected from sound, from people that we do not want to deal with interior. So there's a lot of kind of aspects you could look at for the protection of spaces. And then the origin, it was certainly to give shelter, really to say, and there's kind of this nice, it's a Vitruvian drawing, it's actually from Filarete, who's kind of how the man is kind of exposed to the climate, and then he starts to build a shelter. I put this image that you've already seen, and I also like it a lot. It's It's from Marc-Antoine Logier, who wrote an essay about architecture in the 18th century, kind of looking at what is the origin of architecture. He kind of had a feeling that in this time there was so much decoration and kind of he couldn't really see what architecture is about. And he made an argument that actually goes beyond that idea of a shelter that I just mentioned, that the original hut is also something as an origin of architecture that has certain elements that are kind of bearing elements, structural elements, construction actually. That's what you can see here in the background. It's kind of just trees, kind of assembled together to form a very, very rough roof. But it's also what he says is kind of the essence. That's all actually that's needed. And so his argument was to put away everything that is decoration that's kind of added towards it. That's not what the essence of it is. And this was his point to say we should kind of reduce our architecture to these structural elements because they're actually all that we need to do architecture. And here in front you can see kind of all these elements that are kind of a little bit like garbage, kind of taken away from what is the original idea of architecture. So what's the kind of relation of designing and constructing? I hope it becomes a little bit clearer, and kind of to emphasize it a little bit more, there's a very nice quote that I like a lot from Andrea de Platzes. He's actually at ETH Zurich. He's professor for construction and design, so it's like first and second year. And maybe you know that he has written a very big book about construction. It's like this size, very interesting one. And from this book, actually, Constructing Architecture, is this quote. And it says, "For me, designing and constructing are one and the same. I like the idea that the form is the result of construction and material, something concrete. However, I would view the restriction to this formula as a mechanistic reduction, because the shape of the form, intentionally or not, carries information beyond its material and constructive component, an intention." I think there are some very interesting and nice ideas in that quote. It's especially like these two that I would like to focus on, that the form is the result of construction and material. So there's kind of an idea, kind of a way, a method to assemble material, and the material in itself that has certain qualities. And then there's an intention. So it's not only about the material in itself, but there's always a designer who's doing something for something. Yeah, kind of, you have an idea about an architecture, so it's an intention. And what it basically says that construction is never an end in itself. Construction for itself doesn't have a meaning, but it always follows a purpose. There's a kind of an idea behind it. I want to create a space that is safe. I want to create a space that has certain qualities, like this, has a certain size, so we can all meet in here, that has a certain acoustics, etc., etc. So all these, the construction kind of is the means to this intention. And at the same time, it also says the form is a result of construction and material. And it's actually saying we're not designing something out of nothing, but we're actually designing with these materials. We're designing with the materials we are using. We are designing with the elements we are constructing with, and in order to define these spaces that we want to have. So, looking at building materials and kind of the ways of assembling them, we had this quote: "The form is a result of construction and material." So he's pointing out the significance of the material. Finally, we are kind of doing physical elements. We are kind of creating a built environment that is physical, that we can touch, that kind of forms borders, etc. So the materials we're using, they have certain qualities, they have certain abilities and also disabilities, some things that they cannot do. And these are very important if you're constructing. And what materials should we then use? I mean, you certainly have to know the materials and see what you can do with them. In the beginning, it was quite obvious. People needed to work with what they had, what they could find in nature. So it was stone, it was wood, it was earth, basically. Like these three very principal, archaic, the first materials that people were working with, they started to build with. And basically, this led to kind of the formation of very regional construction methods, always depending on what was actually available, what can we construct, because we need something to construct with, so it's actually what nature gives to us. And so you could say kind of what's there, the material, the way then of joining it, which is a technique, and the intention that you have, they form together kind of kind of structures, a kind of an idea of how elements, how space can be formed with these elements. And it always follows kind of the inherent properties of materials, what you can do with it. Yeah, these are again these like three kind of basic materials that people constructed with long before they were architects as such. These are like these traditional materials. It's kind of this aspect of availability, of local building cultures arising from there. And there's one aspect which I think is very interesting and very important. It's always about scarcity, because you had kind of really to take the material, put some effort into it. So there's always, right from the beginning, the need not to, kind of use material as kind of thinking you could have as much as you like, but there's always kind of a scarcity, and it forced people right from the beginning to think about how can I build in an efficient way, not using too much material, just using what I need to do what I want to do. There's certainly a development about industrial materials, and just to mention kind of the two most important one, it's concrete and steel. As really industrial, cultural developments, it came long after that, and there's, you all know, a full variety of further materials used in construction. But these are kind of the main, let's say, core materials for structural elements, load-bearing elements. I use the term of structure, which obviously has a lot to do with construction. It's kind of the same word source. And actually it means something very similar to a system. It's construction, structure is something that is kind of joining together elements, where elements act together in a system, and that also create over different scales a relation within the structure. And you could kind of look at it, how things are assembled, and what kind of main principles you could discover. You can really see there's like two ways of assembling materials, and or let's say of kind of creating structures, built structures. It's a massive construction that kind of works with material as a whole, planar elements, walls, and the skeleton construction, which is formed of linear elements. And these are kind of representations of what that means, because you can already see the way the space is created is very different in these two ways. You have completely different spatial atmosphere in the upper one, in the massive construction, and they have in the skeleton construction. If you look a little bit closer into it, you could say there's a massive construction. It's kind of planar elements that define that are kind of load bearing. So kind of the roof sits on top of the walls. And at the same time, it forms the enclosure of the space. And there's a certain primacy of the space, which is really very, let's say, it's kind of, it's a very strong envelope that you put around the space. It's forming a body to the outside. It's forming an enclosed space to the inside. And there's a very sharp separation between the inside and the outside. You have a wall, you have a in front, and you have a behind. If you want to do openings, basically, if you have a wall, you have to cut a hole into the wall. You could kind of say the wall is there first, and then you put a hole into it. If we look at the skeleton construction, it has a completely different logic. It's assembled from linear elements, has a separation of the bearing structure and the enclosure. You just have the linear elements that are not planar, that cannot create a surface in themselves. So you kind of have to do a surface and enclosure separately. And there's kind of a primacy of the structure. You see the structure as such, which is kind of defining the space, just like by marking these corners in this case. They're forming a grid to the outside. And there's no sharp space limit. It's kind of a rather flowing space. I'm pretty sure you've heard about this already. The 5 points for a new architecture from Le Corbusier was actually, well, a little more than 100 years ago, was exactly in that discussion. There was a lot of construction done as a massive construction, and he said, I want a new architecture. There's new possibilities, technical possibilities. We can put pillars instead of walls. We can make the separations between spaces independently from the bearing structure and give it a completely different shape. We can do a different way of openings. So it's really something that we could even in that case say it became something like a political program to create new spaces. And you can see kind of from these sketches, very diagrammatic sketches, but they already say a lot about the different qualities of spaces that are created with these two methods, skeleton versus a massive construction. And I'm not judging it. Le Corbusier was pretty clear about it. I think they both are very interesting because they have their, it always depends on what do you want to do? What kind of space do you want to create? Yeah, here again, it's kind of this kind of essence of his point of creating this kind of free floor slabs that you could subdivide in a very flexible way. That's a maison domino. So the materials, going back to that, the materials, they have kind of an inherent logic. They have kind of, we can say, take for example a stone, which is a very small element, kind of that you need a lot of to put together to form a wall, and you kind of need to assemble it in a way, and it's a way of layering. You could use clay in a similar way, or you could do it as a massive construction, a morph construction. And then you have wood, which is completely different because, as we all know, and if you look outside, wood is a linear element. Yeah? It's kind of, it's not, and it has very different properties depending on the direction. Yeah? It can carry a lot of load in the longitudinal way, and is not that good in the transversal way. And it has, from nature, kind of this linear extension. So it's obvious you need to work with it in a different way. And then you could say, okay, if I have a certain logic, I can just use it this way or that way. And I think this logic is something very strong, but it still allows for a lot, even if you follow this logic, it still allows for a lot of different you could call it maybe phenotypes or like expressions, a way of finally assembling them within a set of rules that are given by the material. And actually, in my last vacation, I found a very nice example. It was a small village, basically in southern France, and they just used kind of stones that they found on their fields to do their constructions. It's a very archaic way of assembling. And there was a nice exhibition actually about these types of structures, and there are a lot actually. I actually knew them from pictures from Italy, but you can find them all over Southern Europe at least. So they had these like, this table. It's really showing how many different ways are there to work with that stone, how many different ways are there to assemble them and create spaces in a different way. Still following these same rules, the same kind of assembling rules that lie within the material, because else it would just not hold. Yeah? It needs kind of, you need to lay it somehow, and there's a little bit like an overview where these examples come from. It's mainly southern France and Spain, Italy. So it has a lot to do with availability. Rather dry areas, not so many trees, but stones a lot. So let's use them to build. And it's kind of this principle of layering. And it has a principle of the false arc to assemble the stones, kind of to do the roofing. Yeah? So there's kind of this arc, I'm pretty sure you know about that, which kind of has, by the shape and the way the stones are assembled, kind of creates a stable kind of covering of the opening. And then you have this, what is called a false arc, because it's not really working with this geometry, but it's kind of cantilevering the stones even a little bit more from both sides until they meet. And this is actually the principle that's used in most of these structures. And I'm just kind of run through the different, all from this table, there's different shapes that are created by actually the same technique. And it's a lot of actually round structures, but could also be kind of rectangular walls and kind of a shape that morphs into a round cupola. And I just think it's very astonishing how many different shapes with the same set, with the same material, the same rules, people can create. That's about the intention. That's about actually what do I want to do with it? What shape is the right one for me for what I'm using this building for? Yeah, it's kind of a small excursus to kind of show, even though there's a fixed set of rules, you shouldn't not be afraid of, because there's still a lot of liberty. And talking about that and talking about university, it just reminded me of a book that I found a couple of years ago that I really like. It's also about first year construction and basis of architecture from Professor Annette Spiro from ETH Zurich as well. And she kind of makes exercises with her students about 3 principles of joining materials together. So it's a technique of casting, it's a technique of layering, and a technique of frameworks. And so it's kind of this monolithic material, could be clay, earth, which has a morph structure to create solid construction. And this then kind of these exercises look like this. You can see that there's kind of a form that the form work that is used to create certain spaces, which is very important in this technique of casting. There's also this principle of layering that you actually do with stones, smaller elements. It's a layered structure. It's a solid construction. You can kind of work on it kind of to make it a bit like permeable. And it has a very modular logic. So if you're working with brick someday, you will see that it has a very strong logic, and still there's a lot of possibility to create different shapes, to use it in a different way, still following the same rule and this principle of layering. And you also have kind of this framework, linear constructions, often done in wood. I already explained why, because it naturally has this property. So the solved structures, skeleton constructions with this linear material that then again could be used in a very, very different way. There's a very nice quote, and I will try to get the video. It's online. I hope it works fine. By Louis Kahn. Have you heard of Louis Kahn? It's he's kind of mid of last century architect, a very important one actually. By his time, like all my teachers were saying it. He was kind of their master in a way, and he actually was working a lot with the properties of materials, kind of this. So try to get the
design demands that one understands the order. When you are dealing or designing in brick, you must ask brick what it wants or what it can do. And if you ask brick what it wants, it'll say, well, I like an arch. And then you say, but arches are difficult to make, they cost more money. I think you can use concrete across your opening equally as well. But the brick says, oh, I know you're right, but you know, if you ask me what I like an arch. and one says, well, now, why be so stubborn, you know? And the arch says, may I just make a little remark? Do you realize you're talking about a beam, and the beam of brick is an arch? That's knowing the order. It's knowing its nature. It's knowing what it can do. And respect that tremendously. If you're dealing with brick, don't just use it as another kind of secondary availability, or that it's cheaper. No, you got to put it into absolute glory. It is the only position that it deserves. It deserves that point. If you're dealing with concrete.
So, I think the message is clear. These elements, they have some logic, and really to make them and really use them properly, also as an architectural expression, it really means to know how they work, not kind of to misuse them in a way. So, this is the quote we just heard. And he was working with it as a, I think, very, very nice way, kind of using this and having this opening kind of as a partial arc, and kind of with a concrete element combined and using the properties of each of these materials. Scarcity. Okay. Here we go. Yeah. I kind of mentioned that when we're talking about the materials already, and scarcity is, as I think, one of the one of the very important driver or way of thinking. How do I use material? How extensive do I use it, or how reduced can I use it? And a lot of construction is actually about dealing with scarcity, because taking materials, creating them is always related to an effort. You have to kind of take them out of nature, you have to form the bricks, and it's a lot of work, or a lot of energy that you put into it. So there's always this pursuit for efficiency in construction. This is a very old, it's actually 2,000 years old, wooden structures. And you can see that actually we talked about wood, which is a linear element. It's very difficult to make surfaces with, and they kind of used it as an addition of materials of these trees, basically, that they put next to each other, which is certainly a way to create then a surface, a wall that is closed. It's actually a lot of material that is used, and it's much more than actually the building in itself would need as a bearing structure. And you can see that it's kind of the material is used in two different ways. And we see that you have kind of this linear logic that kind of forms these main bearing elements of the roof and the corners that define the corners, and then you have kind of this surface of the wall, which is the same form of the same material, but it's not a very efficient way to use the material. And so the architects and engineers through thousands of years, you could say, worked on that, kind of to reduce the use of material, to make it more efficient. So in wood you could also construct like this, kind of a truss, very reduced, very limited in the material that you actually use, but assembled in a very clever way that the forces can actually be transmitted through this material and this kind of dissolved structure and this dissolved construction of the truss. And it goes even further, and there's no end to it yet. This is also a very nice wooden structure, Multihalle in Mannheim in Germany, by Mutschler, Langner und Frei Otto, who's kind of, Frei Otto is someone in between an architect and an engineer. The latest German Pritzker Prize. It's kind of really, you can see how basically like this really wide span is kind of done with a minimum of material. And you could say, okay, this is a kind of a hard topic, and that's how I explained it. I always had to do something with it. But we are in a situation right now where it's again it becomes obvious again. It's never been different that to take resources requires an effort. And we are actually right now in a crisis of resources. So it just becomes much more important again. Though it's not actually a new knowledge that we are in a limited, let's say in a limited world. We have, I like this photo a lot, was taken from the moon, and it's kind of this Earthrise, so the other way around, the other perspective, and we can really see how limited actually it's kind of a big ecosystem, but it has its limits. It's a soul in itself, so it's limited. And you can see this limitation in this picture. And kind of this awareness, I also like this picture a lot, which is what is called the overview effect, that they're actually becoming aware of the limitation of the environment, not when you're in it, but actually when you look over it. So this is actually an American astronaut looking at the Earth from above and kind of, then really feeling the limitation. So it's a system of limited resources that we have to deal with and have to be careful with. And this is actually like a knowledge that is not new. The Limits of Growth is a book from the 60s or the 70s, around 1970, which actually already pointed that out. And we're still having these discussions until now, but we are more aware of it because actually we see that the effects right now, we see the limitations in many, many ways. So there's the limitation of material resources, And there's even like a scarcity in this way of sand, which you would say, well, as much sand as in the desert, this one's too fine. It doesn't work for a concrete construction. So to have the proper sand for the concrete that is needed on the world is really becoming a scarce resource, which is something that you would actually never expect. So it's the limited material resources. It's the use of the carbon-based energy and the climate change caused by it. And the building sector has a big factor in it. Well, it depends always a little bit how you account for it, but it's around 40% of the energy use worldwide is based from CO2 emissions are actually coming from the building sector worldwide. And it's 50% of the waste that is produced, buildings that are kind of thrown away. So these are actually like very, very important issues to deal with. And yeah, there's certainly strategies to deal with it. There's the use of, or the reuse of buildings, saving materials, saving the energy that was once put into these materials to produce them, or the reuse of building elements in themselves, which is becoming, yeah, it's a discussion that's going on right now. How could that work actually, to reuse building elements, to reuse windows, to trusses, etc. And there's also certainly a look for new materials, renewable materials. So it's kind of materials that were used before, like wood, but they're kind of manufactured in a very different way. Or like this, we can kind of see it's like profiles of wood that you would usually not use in construction because they're too thin. But also there's a lot of that actually, and it's a renewable resource. It binds a lot of carbon, and so it could be a very interesting material, but the question is, how do we use it properly? So this is actually this topic and this aspect of scarcity is something very important. And it was from the beginning, and it is until now, and there's a new awareness actually of it, which I think is very interesting. And now coming kind of to the main core, how can structure actually be used to create space? How could that work? And I actually like these two images a lot. They're from an Italian, also architect engineer, Luigi Nervi, who was building with concrete, with steel. He did these two big halls, a sports hall on the right side, Palazzetto dello Sport in Rome, and Palazzo del Lavoro, kind of an exhibition hall, you could say, on the left side. I showed it a little bit bigger because I think they have they are very strong structures that define the spaces, and that actually there's not so much more elements than these main bearing structures that really defining the character of the space. So you have this, kind of mushroom-like non-directional elements added to each other. You could actually extend it virtually to whatever dimensions you would like. A very open facade, and this kind of light coming through these elements. And then there's this Palazzetto dello Sport, which has a completely different atmosphere. It's not like open to the sides, even though it has this window, but it's really like a very protected, a very kind of hold, embraced space, you could say. And you can see that the structure is different, even though in both cases you use it as kind of as a formal expression. In this case, it's actually precast elements that were cast in place, then to kind of combine to this cupola, to this shell, and but they create a completely different space, this embraced space versus this kind of open, flowing space. And I think this is a very nice example to kind of see how even with the same way of thinking, you can create very, very different spaces. There's always certainly an outside to the inside. I'm showing this interior spaces where you can mainly see the structure. In this case, it kind of also shines to the outside. So there's a volume connected to it. And also a very different one at the Palazzetto dello Sport. Also to the outside works in a very different way. So there's actually very much depending on which structure, what system are you using, what geometry you're using, and what structural system you're using. You could create a very different expression of your spaces. And I think it's a big opportunity not to hide these structural elements, but really to use them because they are there. Kind of thinking back to Logier, they are there and you can work with them. And you can really use them because they're there already to express and look for the right system to kind of support my idea of a space, of how a space is covered. So there's a support grid which is non-directional, which kind of works in both ways. It's a little bit like kind of this. It's a different system, but kind of a same non-directional logic as we've seen in the Palazzo del Lavoro. And then there's kind of this directional that basically work with either beams on columns or frames where they're kind of added in a row, set in a row, and then the spaces, as you can see, they are stretched. They kind of get a direction. So we can emphasize through the structure what kind of space is it. Is it like a space that has a center? Is it an open space? Is it a stretched space? And that is kind of one of these core elements of the properties of a space. And there's certainly a lot more. There's kind of this principal systems, kind of that also have a certain logic in themselves. And there's a lot of different ways to do it, and kind of to really, it's a little bit like this, this principle with the stone houses, the trulli structures that I showed to you. There's a lot of different ways to do it, and work with these different systems. And they create very different spaces. So this is like a non-directional space. You can see like there's no, in the roof structure, you have kind of both directions have the same layer, the same importance, you could say. And they're sitting on columns. And this is kind of a truss-based hierarchical system. So there's like a big, very dissolved truss in this way, and then kind of a secondary, much smaller one in the other direction. So the space kind of gets in a direction. Or this one, which is a kind of a, also like really, even by the shape, kind of covering and even more emphasizing this this direction of the space. Or these frames that are doing more or less the same. So they have kind of a rather short sequence in one direction and a longitudinal direction, and then kind of this wide span in the other direction. And they create very different spaces. So it's kind of really to show how the character of the space is formed by the structure. If I use it really, and I'm showing it, if I make it visible, in order really to make it working. And there's a lot more aspects. So it's like these principal systems. So it depends on the material, certainly. Do I use steel or do I use wood? Timber construction or maybe concrete. It's the system, the structural system in itself. And I showed a couple of these kind of to see how the system in itself and its logic already gives you kind of a different atmosphere. But still there are much more things that you can manipulate and work on. You could look for the geometry. We had this kind of radial space. We have rectangular spaces. The dimensions could be very different. The position of the columns could be on the outside or maybe like a little bit to the inside with a cantilever to the sides. There's a shape of structural elements are they kind of strong sitting columns? Is it? Do they have? They rather fine elements? You can see this, actually from this main principle. These are like two non-directional roof structures, and both made out of steel. And so, kind of in this main principle, they have some in their principal logic. They have similarities, but they look so different. They have such a different. The one above is very light. It has it's kind of really dissolved to the minimum of material, while the lower one is completely heavy. And maybe you don't know that the upper one is a sports hall in Spain. The lower one is the National Gallery in Berlin from Mies van der Rohe. And it has a really, and you can see it and feel it in this picture, it has a really strong, very heavy roof, very strong structural elements. So very completely different atmosphere. And then you could still work on and manipulate the rhythm, to have wider spans in between these elements. And the detailing, there's a lot of kind of parameters you could work with to create different atmospheres with the structure. Yeah, here you can see it again. The space is a very light roof structure. Another one actually made out of wood, also a non-directional system. Kind of the elements on the same level, they are made in the same way in both directions. And then this very heavy steel structure with a very wide span that really spans from one edge to the other. So these elements inside, they're not barren. And you can see it here again that, you have this non-directional, these elements, the decision to put the columns on the very edges on the outside. This is a completely open facade, which is kind of recessed a little bit to the inside. So you have a cantilever of the roof. And then also the way of detailing has a lot to do with how the structure as a system works. So these are they are stiffly fixed columns. And then kind of the roof is set on top. So like this upper point where the roof and the column meets, it can be very fine. You can see how reduced it is and how Mies van der Rohe makes it legible, how actually the system works. He uses it as an aesthetic expression to work with this. And so it's actually like all these layers work together and they form a whole as a system to create an architectural expression. This is another example. Now a directional space with trusses, or let's in the upper one it's framed as a sports hall in Switzerland with a very dense rhythm. It's about maybe to explain how different the rhythms can be and how different the spaces then become. There's a very it's maybe just like a meter or a meter 50 in between these frames of timber and the upper picture, and it makes a very dense, actually, has a very dense rhythm, and it's much wider on the lower one, and creates a completely different atmosphere in the space. Yeah, here again, kind of this very dense rhythm to see how actually a system works together with the exterior, the form, and as well kind of this play of volumes in this case, and this very dense sequence of structural elements. Yeah, another example, kind of really to see how different these elements can be. This kind of mushroom-like structure, and then actually the completely opposite of it. Again, Mies van der Rohe National Gallery that kind of has this plate that is put on 8 columns on the edges, and a completely different logic on the other side with these mushrooms that kind of from the middle extend, and they create a different space, even though there's similarities, as you can see, kind of this this wide facade, this glass facade that actually has no limits. Yeah, here again a little bit larger, and the other space, and see how different they the atmosphere is. Okay, I didn't make a break. I was announcing a break, but anyway, because I'm always almost at the end. And would just like to show a couple of examples still to point out certain aspects about structure and construction and how that actually can, on which layers it can relate to the expression of architecture. So this is actually a mountable sculpture in a coal mining area in Germany, Saarland. It's made out of steel. It was kind of as a monument to the end of that era because they stopped coal mining around 10 years ago and wanted something to memorize that era, and that also had to have a notion of future. Yeah? So it's placed on a artificial mountain on top with a wide view. Has this shape of these kind of three tubes. And there was a very important kind of design driving idea of having something that is changing, because it was kind of what the client was asking for. I want something that kind of represents the change from the past to the future. So something like a development, and the idea was actually to create a three-dimensional sculpture that, if you look at it from different perspectives, basically creates a different shape, very different shape that can be read symbolistically or just as an abstract change of the appearance of the element. It also changes from day to night using the light in the interior. And the thing that was very design driving in this case was actually kind of to give the structure I would say an atmosphere, kind of the feeling of association with these coal mining structures. So it had to be something that is somehow similar without copying it. It's not exactly this, but it has something in its logic that is similar to it. It's kind of coming from there. And there was this on the above ground, this very strong these elements, these linear elements, these tubes that kind of became the inspiration and kind of made this sculpture as readable as something that is from the same family, has the same logic. And this on this associative level, they can really say, okay, there's this kind of tube-like that's represented in the form and the shape of the sculpture, and then there's also the structure and space and the way things are assembled, the way the materials are used. So it's steel, as it was used a lot underground. It's also it's kind of certain spatial familiarity, you could say. So the thing is assembled actually of a main bearing structure and circulation, and then it has kind of still like this surface, this facade going around, which is completely open. It's a grid, but still kind of completes the form as a whole. And then from the inside, it reads like this. And it goes down to the detailing. So it's also very, let's say, rather rough, very industrial detailing. But we've discussed it a lot actually with the engineers and with the companies, how to do it and kind of to give it a certain hierarchy, make it really readable in the way that we wanted to have it. And so actually the whole thing needs to work together on these different scales. It has different scales as a shape, as a whole, kind of this idea of this three-dimensional sculpture that changes its appearance when you walk around it, of the atmosphere of the space itself that has some relation to these old coal mining structures, and then kind of the creative detailing that is also reads as something that is important for the atmosphere. And the detailing is important for the atmosphere because you see these things, you perceive them. So this is something kind of, and you can see it's not about just building. It's just not one layer you are looking at. It's not only about the shape, but it has more aspects to it, and that's what I want to point out with this example. I'm always also trying to do this at the university and kind of work with structures and use expression of structures and kind of but creating them as a whole, as a system. So there's this really beautiful image that I like so much on the left side. And it was a lot about detail and the system. So how do they kind of interact? How do they kind of kind of one is a reason for the other. They are linked together. They cannot be thought one without the other. So there's a certain logic of joining things that is then represented in the whole, and kind of the whole that requires a certain way of joining elements and cannot think one without the other. And so this one student work from Nils Konrad, they actually worked with bamboo. And wanted to do this kind of very centered structure and found a geometry, how to join these elements together, but they worked further. It's kind of the atmosphere, and it's all of these joints, actually, they give kind of as a pattern, they give something to the structure that you read as someone being there or someone looking at it. You can see all these joints are visible in a way, and they give a kind of a surface pattern to the structure as a whole. And so they were like developing this and even developing the details. How would you then join this? How do you do the foundations with this material? How do other joints made? And then even build like large-scale models to show how that works. And actually, while developing the details, the overall shape changed. And so there's really this interdependency between these two levels. And that's what I want to point out with this. It's also like this one you've already seen, which is a similar case, same semester, same project. Also like an overall idea, a system, how the elements join together, and then really like looking at the details, how can I really make the elements do and work in that way and transmit the forces in that way that the structure works as a whole. It's the overall, the system and the detail. And then certainly there's a lot to expose afterwards. So it was a lot of also case studies done, and then kind of principles, learning principles, and then kind of transmitting them into your own design idea. And well, this is the last project. It's a current one that we're working on right now, and I've shown these timber thinnings, these very small wood profiles that are industrially actually not used yet because you cannot efficiently work with them. Most of the machines, they are too small for most of the machines really to work efficiently. And we have actually a lot of that material because there's a change in the woods, there's a climate change. So actually there's a lot of this rather small material taken out of the woods, of the forests. And you can basically just cut it down right now. It's what's done with that material and have a minor use for it. Yeah? So it's transformed into plates, wood plates. And we are just looking at how else could you do it, and how could you maybe also work with it as an architecture. And we see this is an element that is, has certain properties. It has a lot of difficulties because it's not, you don't have like a profile that's the same all along, but it changes dimensions, changes direction a little bit. So it's actually a difficult material. We were just like looking at how with our students what could we do with it? How can we create space with these elements, and then looking further, could we join it? How could we then solve all these issues that come from that material that it brings with it as properties? So was again in the beginning looking at examples, case studies, analyzing them as a system, but also already as a detail. And then looking for references that might be interesting to kind of work with these principles. So this is like one of the case study analysis elements. This is actually a project. The original project is, so it's a details. It's still the analysis phase. It's actually this project on the Hook Park. It's called Field Station. It's from the AA, an Architecture Association in London, a project that they're doing with their students, really to see they kind of have this field and these woods that they're working on, and they're working a lot actually with these timber thinnings, with these very thin profiles, and see how can we kind of manufacture them? How can we? In what way can they be used? And so our students made a couple of proposals for this. This is just one of them, kind of with a roof structure, a little bit similar, or familiarities that certainly got inspired. Though it works a little different, and our intention is we kind of went to the next step and really see how does the manufacturing work with that, and said, okay, we need to kind of really try it out. We need what are the ways to join these elements together? So our students built large-scale models, 1:3, 1:2 scale, with these profiles, 4 different proposals for spatial structures. That all of them have certain, have kind of their principle, and they have certain aesthetics. Some of them are using a lot of material, like this one on the left side, and others, like this one in the back, which I've also seen here, really reduces the amount of, this one really reduces the amount of wood elements very much. It's very, very few structural elements that you need. And so the material is these timber thinnings, and you can see how kind of irregular the material is, and can imagine that it causes a lot of issues that need to be resolved. So at the end of my lecture, kind of trying to give you an idea what I think is so fascinating about structures and how to use them as kind of how they can support, how they can actually form the spatial expression of architecture, and how that always is connected between the whole, a spatial idea of a whole, and the way actually breaking it down even to the detailing. Thank you very much.